Good day, grade 12 learners. Welcome to today's technical science lesson. My name is Thabang Mongatani. This lesson is brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center and broadcast by Pagama Research and Development. Today, as it is the 17th, we will be focusing on work, energy, and power. Knowing that we did work and energy before, today we'll be focusing more on power. On the slide, this is what the structure of paper 1. We say in paper 1, we have 3 sections, which is mechanics, electricity and magnetism, wave, sound, and light. And then this is the mark allocations in a exam, whether a prelim or a final exam. Mechanics is out of 93. Electricity and magnetism is out of 33. And wave, sound, and light is out of 24 marks. The weighting out of 100% will be mechanics is 62%, electricity and magnetism is 22%, wave, sound, and light is 16% of paper 1. And then we say paper 1 is out of 150 marks. And then when you write paper 1, whether in prelim or in final exam, you'll be writing for 3 hours. We don't give more than that. It's 3 hours strictly so. And then learn that every time when you write a exam, you don't go out of the exam room before the 3 hour is exhausted. And then the weighting of questions across the cognitive level is we have level 1, which are in a technical science are like definitions and the things that you are able to remember. They take 25% of the paper. And then level 2, which are easy calculations and some of the easy explanations is 30%, and level 3 it takes 40%, and level 4, which is a higher level, is taking 5%. And then if you'll be having a question during this presentation, please you can WhatsApp the question on this number 060-667-5044. Let me repeat the number. WhatsApp number is 060-667-5044. Grade 12s, as we know, work. We started with, in work, energy and power, we started with work as a first lesson. Then that means work was already done. And then the second lesson, it was on energy. And then all this that you see in energy, it has been covered. Today, we will be focusing on yellow highlighted, which is power and velocity. That is our lesson today. We'll be putting more on that. But we're bringing this because power, to be able to do power, you need work and you need energy. You'll see when we do the exercises, work is needed or energy. Work and or energy is needed to do power. Marks allocation in paper 1. In section A, you will have 10 multiple choice questions, which each multiple choice question is 2 marks. Then if you have 10 of them, that means it will be out of 20 marks. And then we have a section B, which is structured or long question. That's where you get the definitions and the calculations. It is out of 130 marks. Then the total of the paper, as we mentioned before, is out of 150 marks. And duration is 3 hours. We can't do work if we don't have a formula sheet. The formula sheet, when you write a test or an exam, the formula sheet will be given to you. Normally, we put the formula sheet, the formula sheet at the back of the question paper. This, we just took a snapshot of work in the formulas. We took the snapshot of the formulas from the formula sheet that are dealing with what? Work, energy, and power. We say work and energy and power in an exam, it takes plus minus 20 marks. And then the formula sheet, when you check on the formula sheet, you can see that the first formula there is for work. We say work is equals to force multiplied by displacement at the angle of cos theta. And then the second one is what? Is kinetic energy. Kinetic energy, we say, is represented by K or E subscript K. We say kinetic energy is equals to half mass multiplied by velocity squared. Then we have what? Mechanical energy. Mechanical energy is what? Is kinetic energy plus potential, gravitational potential energy. And then you can see at the top there on the right, we have what? We have a gravitational potential energy, which is represented by letter U, capital caps U, or E subscript P. And then we say gravitational potential energy is equals to mass multiplied by gravitational acceleration multiplied by the height. And then we see that we have change in kinetic energy. The formula to calculate change in kinetic energy is what? Is kinetic energy, final kinetic energy minus initial kinetic energy. Then we come to power, which is the main topic today. We say power is equals to work divided by time. When you see this, you must always know that it represents what? Change in time, which in short is what? Time interval. Then power, it can be calculated by using 2 formulas. The first one, this is the first formula to calculate power, and this one is going to be the second formula. Sometimes you'll find that when you read the question, you are not given work, but you are given what? force and velocity. Then you can use force and velocity to calculate power. What does the symbol on the symbols on the formula stands for? We're gonna separate it nicely so that you understand that every time when you see the following symbols, what are they stand for? This will help you also when you're doing the calculation, that you don't put the wrong value on the wrong symbol. Okay, from the formula of work that says work is equals to force multiplied by displacement, we say this is W is work, F is force, and changing X is what? Is displacement. And then this is the angle between the force and the displacement. Cos theta is the angle between the force and the displacement. We say here where W stands for what? Work. And work, the SI unit for work is what? Is joules. That means we use joules to measure work. And then the symbol for joule is what? Is capital letter J. That means every time when you completed your work calculation, it must follow by what? Capital letter J. And then we go now to force. F stands for force, and then force is measured in what? In Newton. And the symbol for Newton is capital letter N. That means if you don't want to write Newton in full, you can write what? Capital letter N. We know that it stands for what? Newton, and is the SI unit of what? Of force. Then we go to change in X. Remember the triangle, it stands for change, and X. A change of X, it stands for what? Displacement. It is what? Displacement. It stands for what? Displacement, and displacement is measured in what? In meters. And then meters, the symbol for meter is what? Is M. Okay, from the formula of what? Potential gravitational energy, we use what? U, as I mentioned before, and then we say U is equals to mgh, or we can use what? EP, which is still stands for what? Gravitational potential energy, which is equals to mg. U and P and EP stands for what? Gravitational potential energy, and it is measured in what? In joules, like work. And then the symbol of joules we say is what? Is capital letter J. And then when you see this M here, this M stands for what? Mass. Others will say mass or mass, and then it is M stands for what? It stands for mass, and it is measured in what? Kilogram. The SI unit for mass is what? Kilogram. And if you are given mass in grams, that means you need to convert it into kilograms. We don't work with grams, we work with what? Kilograms. And then the symbol for kilograms is what? kg. And then we have this G here. Grade 12, please don't confuse this G with this G here. This G that you see here is for SI unit. But this G that you see here, this G here is for what? It stands for what? Gravitational acceleration. It's not grams. It's what? A gravitational acceleration. And it is measured in what? Meters per second squared. Meters per second squared. And then this G that you see here, it is a constant number. It is always given to you as 9.8 meters per second squared. It is always given to you as what? 9.8 meters per second squared. It is always given to you. It is like, it doesn't change. It's always 9.8. It is a constant number. It doesn't change. And then we go to what? H. H stands for height. Height is from the ground to up. We start from the ground and we're going up. Then, and height is measured in what? In meters. Height is measured in what? In meters. And then as we mentioned before, meters, it is what? The symbol for meters is what? Is M. We continue with explaining the symbols that we found in the formulas. And all these formulas, grade 12, we found them on the information or on the formula sheet. They are always given to you. You don't have to memorize them. You don't have to memorize them. Okay, we go on. We're saying now we're looking at the kinetic energy formula, which says Ke is equals to half mv squared. Or if you don't want to say Ke, we said we can say Ek. We can say what? Ek. Then we say Ke or Ek stand for what? Kinetic energy. And it is what? It is measured in joules, like potential energy, like work. They are all measured in what? In joules. And the symbol for joules is what? Is capital letter J. Then now we're coming to what? This V that you see here is the same V that you see here. It stands for what? Velocity. And is measured in what? Meters per second. When you see this, you must know it is what? It is what? It is when you see this, it is stands for what? Meters per second. Are we together, grade 12? Yes. And then that is the SI unit for what? For our velocity. Then we go and look at what? Mechanical energy. Mechanical energy, as we mentioned before, we said is what? Is ME, which is equals to kinetic energy plus potential energy. And then we say ME stands for what? Mechanical energy. And then we mentioned this, that it stands for what? Kinetic energy. And this stands for what? Potential energy. Then we're coming to the lesson, the main lesson of today, which is power. Power, we use is either we use what? To calculate power is either we use P is equals to work divided by time, or energy. Energy divided by what? Divided by time. Because work and energy, they are equivalent to each other. We say now P stands for power, and then as we mentioned, we say now this smaller triangle, it is for what? It means change. And then this, it stands for what? Time interval. And E that you see, it stands for what? It stands for energy. And energy, we know that is for what? Energy is measured in what? is measured in joules, and W that you see here is what? Is work. Is work, my learners, is work. And also work is measured in what? In joules. Okay, this is the formula again. You can see power. And then we say the definition of power. What is power? To look at the definition, nicely go to your teacher and ask the copy of exam guideline. If the teacher can give you, yes, you'll be able to give you, because all the definition, we follow the definitions from exam guideline, because exam guideline is the policy. We can't change policy, my grade 12. We always follow policy. Then in the exam guideline, you'll see that power is defined as what? The rate at which work is done. Is what? The rate at which work is done. And this is how we're expecting you to define power, whether in a classwork or a homework or a test or a exam. We expect, if we say to you, define power, that means we're expecting you to say power is defined as what? The rate at which work is done. Okay, we say now power, the SI units for power is what? W-A-T-T. W-A-T-T. And the symbol for watt is what? Capital letter W. The symbol for watt is what? Capital letter W. And then when we're dealing with power, you'll find that power is given as a big number. And that big number, we call it what? Is kilowatts. And then we know that kilo, when you see this K, it stands for what? Kilo. And in kilo, it means what? 1,000. Kilo, it means what? 1,000. When you say kW, that means it says what? Kilowatt. Then we say kilowatts is equals to 1,000 watts. Number grade 12. If you have any question, please, you can send it on WhatsApp. And the number is still 060-667-5044. Okay, in power, we have something that we call horsepower. Horsepower is equals to 746 watts. 746 watts. And then you grade 12s, because you know more of horsepower. Horsepower is the power that the car engine is produced. You know more than me when it comes to cars and how powerful is the car. And then you'll see now, you'll want your car to have this big sound. Yes, I don't know more about that, but you know more. Horsepower is coming from there. The engine is the engine power. We say, my grade 12, power is a scalar quantity. Power is what? A scalar quantity. What do we mean when we say a power is a scalar quantity? We know that a scalar quantity is a physical quantity that has only magnitude. That means power doesn't have a direction. It does not have a direction. You can't say 100 watts to the right, or 100 watts forward. No. That means power doesn't have a direction. And then in technical science, we say we solve the problems involving work, power, and time. Why work? Why time? Why power? All of these, they come from this formula, because on the formula for power we have P. Power is equals to work divided by what? Time. That means, my grade 12, they can ask you, they can give you power and time, and they ask you to calculate what? Work. Or they can give you power and work, and they ask you to calculate what? Time. Okay, our first example, I chose the multiple choice because multiple choice grade 12 is very, very important. Just imagine 20 marks. 20 marks comes from where? Multiple choice. We must be able to answer multiple choice. We're not gonna, and when we answer multiple choice, we don't just pick any letter. No. We read the question and we read it again until we understand what is needed from the question. Like, let's read the question together. It says, which of the following expressions can be used to calculate the power exerted on the object? Which of the following expressions, how many expressions are we given? A, B, C, D. We're given 4 expressions. Then, which one out of these 4 can be used to calculate power? And then we know the formula for power is what? P is equals to W over what? Over time. Then, is it A? That means to calculate power, we must have what? Work and what? And time. Let's look at A. Does A has a W, which is work? No. Does it have time? No. That means A, it can be the expression that we use to calculate what? Power. Then we go to the second one. We see the second, a B, it has what? A force and a displacement. And then is what? It says force multiplied by what? Displacement. Is that correct? Is that the expression that we're looking for? No. Then we go to the third one. C, it has what? Energy. And it has what? Displacement. And then we said work and energy, they are equivalent to each other. That means work is fine, yes, but the problem is what? Displacement. That means our answer is going to be what? Is going to be D, because the expression is what? Work divided by what? By time. That is the expression that we're going to use to calculate what? To calculate power. Okay. We have another example. We're going to take only 1 minute. 1 minute. Strictly 1 minute. Before we take that 1 minute to do this, we're going to say, let me just go through it with you so that where you don't struggle. It says, we said first we read what? We read the question before we go to choose the correct answer. The graph it says the graph represents the relationship between work. This is work. Can you see? The relationship between work or on an object and the time. This is the time taken. And then they say the gradient of the graph represent. What does, in short, it means what does the gradient of the graph represent? What does the gradient mean? It means the slope. Can you see this line here? How it goes? Then the slope, it means it's the same as what? When they ask you what is the gradient is what? Is the slope. Then we want to know what is the slope. And then how do we get the slope? The slope, we get the slope by doing what? By dividing this. By dividing this with this. I think now I've given you the answer. Let's take, we're saying now, we take this to get the slope. We take what? We take this, we divide it with what? With this. Then it will give us the slope. And then the question is, what is the slope of the graph represent? And then we know that we say work divided by time. Let's take 1 hour, 1 minute to go through this grade 12s. Thank you, grade 12s. We are back. I think now you have the correct answer to our question. We say, I know you got it correct. For those who didn't get it correct, we said W, work divided by time. We say the slope, to get the slope or to get the gradient, you must say what? What is on y-axis divide by what is on x-axis. Always. What is on y-axis divide by what is on x-axis. And then on y-axis we have what? Work done. And on x-axis we have what? We have time. Then that is why we can write it like this. And then what does that mean? If you have a work divided by time, what is that? Is it potential energy? No. Is it kinetic energy? No. Is it momentum? No. That means our correct answer is what? Is power. Because when we go back to previous slides, we say P is equals to W is equals to work divided by change in time. That gives us what? Power. Then we're coming to long questions. I'm just gonna do this with you, grade 12. It says, let's go through it together. It says, the question says, every time before you answer any question, make sure that you're doing what? You read the question and understand the question. The question says, we have a statement that says a powerful race car with a mass of 840 kilogram has a maximum power output of 550 horsepower. HP stands for what? Horsepower. And then remember, we said 1 horsepower is equals to 746 watt. Are we together? Remember from the previous slides, 1 horsepower is equals to 746 watts. Then now, the power that we have here is 550. when you have the question like this, the first thing that you do what? You write down the given data. We've given the mass and we've given what? The horsepower. Then we're just going to write them down. We say M is equals to 840 kilogram and horsepower is equals to 550 horsepower. The power that we're given is what? Is 550 horsepower. Okay, question number 1. It says, convert the power of the racing car into what? It says what? Convert the power of a race car into what? Because the power is given into what? Is into horsepower. We need to change those horsepowers into what? Okay, we say first 1 horsepower is equals to 746 watts. Are we together? In order, this is for 1 horsepower. But if you are given 550 horsepower, how much would that will be in what? In watts. Then we just do what? We just do like this. We just say 550 multiplied by 1 horsepower is equals to 550 multiplied by 746 watts. Can you see? Then we know that 550 horsepower is equals to what? What is this? How much is this? 550 multiplied by what? 746. This 6 multiplied by 0 is 0. Then is 30. We write 0, carry 3. Then is 30 plus 3 is 33. Then we come here. We're going to say 4 multiplied by that is what? Is 4 multiplied by 0 is 0. 4 multiplied by 5 is 20. Then we're going to have 0 here. And then 4 multiplied by 5 is another 20. Then remember here we carried 2. Then we're going to have what? 22. Then 7 multiplied by 0 is what? Is 0. 7 multiplied by 5 is 35. Then we write what? We write 5 and then we carry 3. Then 7 multiplied by 5 also is 35. 35 plus 3 is what? 38. Then we have what? 3, 3, 0, 0. And then we have 0, 0, 2, 2. And then we have what? 0. We have 0 and what? 30. We said what? 5. Then we have 35. 38, sorry. 38. Then is 0. Is 0. Is 3. Is 0, carry 1. Then is 1. Then is 4. Then we have what? 41,300 watt. That means 550 horsepower is equals to what? 41,300 watts. If you have any question, you can forward the question to on this number 060-667-5044. Oh, sorry. This is what we have for number 1. And all of this is 2 marks. And then question number 2, it says, calculate the work done by the racing car engine if the race car is driven at maximum power for how long? 12 seconds. That means we're going to go back to what? The formula that we know that says P is equals to W over what? Change in time. And then from there, we do what? We substitute. We do what? We substitute. We know power is what? This stands for what? Power. We have what? 410300 W is equals to W change in what? Divide by what? Divide by 12. Then from there, we multiply both sides by 12. Where does this 12 comes from? This is the 12 that we have. 12 seconds. Then this 12 cancel this 12. We say therefore work is equals to 12 multiplied by 41,300. Then how do we do that? We just say 41,033 multiplied by what? Multiply by 12. Then it's going to give us 0.06028. And then we have 0.03014. Then we have what? The answer is going to be, work is going to be equals to 0.063,294. That means we have what? And work is measured in what? In joules. Work is measured in joules. Then we have how much? 492,000 is what? 4,923,600 joules. That is our work. Then question number 3, it says calculate the power. Okay, they said the power. No. It said the power of an engine is equals to 5,000 watt. The power of an engine is how much? Is 5,000 watt. And then the question is, explain what it means. What does it mean when we say the 500 watt, 5,000 watt? 5,000 watt is simply means you have what? You have 5,000 joule in 1 second. You have what? 5,000 joule in 1 second, or is 5,000 joule per second. Are we together, grade 12s? Thank you very much. Power. We continue with our questions. I want us to take 3 minutes to do this question. You're gonna do it by yourself, and then let me just highlight things here. It says that the statement says, during a weightlifting competition, Themba and Vusi each lift 50 kilogram over a vertical distance of 2 meters. Themba does it in 3 seconds and Vusi does it in 6 seconds. What does that mean? We have 2 boys, Themba and Vusi. They are each carrying what? They're lifting what? An object that weighs 50 kilogram. And then they are moving, they're carrying it on a distance of what? 2 meters. But Themba, he covers these 2 meters in 3 seconds, and Vusi, it takes Vusi 6 seconds to pass these 2 meters. Then the question says, define the term power. What is power? And second question says, which one between Themba and Vusi applied more power? That is the second. Which one between Themba and Vusi apply more power? Let's take 3 minutes to do this. Thank you very much, my grade 12s. Welcome back. I know that you got this also correct. The first question, it says, let's go together with to the statement. The statement says, during a weightlifting competition, Themba and Vusi each lift 50 kilogram over a vertical distance of 2 meters. Themba does it in 3 seconds and Vusi does it in 6 seconds. Then question 1, it says, define power. Grade 12, I forgot to tell you that the formulas that you found, that you see on the formula sheet, they always help you to define. Like now, we know that power is equals to work divided by what? Divided by time. And then, how do we define power? We say power is what? The rate. Is it what? The rate at which work is done. Can you see? The rate at which work is done. What does it mean? Always when you see the formula with that, and then there is time at the denominator, you must know that that is what the rate. This, it tells you is what? It tells you about the rate. And then it says the rate at which what? Work is done. That is how you define power. Power is defined as what? The rate at which work is done. Thank you, my grade 12. Let's go to the second question. Second question, it says, which one between Temba and Vose applied more power? Which one between Temba and Vose applied more power? Okay, the mass is the same. If the mass is the same, then we can use what? We can say work, W, is going to be what? The same. Because of what? Work is equals to F multiplied by what? Multiplied by changing X cos theta. Where cos theta is going to be what? It's going to give us what? Because work, remember when you lift, your force, the force that you're applying is going up. Your force is going up, and the distance that you are traveling is what? You are going to forward. That means the force applied and the distance or the displacement are perpendicular to each other. What does that mean? What is the angle? If work is going up and the displacement is going forward, and that means they are perpendicular to each other. What is the angle? The angle for perpendicular is what? 90 degrees. Is what? 90 degrees. Then when we calculate work, we're gonna say what? Force. No. Okay, we're gonna say what? Sorry, colleagues. Grade 12s. We say now to calculate work. The formula that we're gonna use to calculate power. The formula that we're gonna use to calculate power is what? P is equals to FV, because we're given what? We're given We're given the mass. They want to know which between Temba and Vose applied what? Applied more power. The force that we have here is going to be what? Gravitational force. How do you calculate gravitational force? We say Fg is equals to mass multiplied by G. Then we know that mass is how much? Is 50 multiplied by 9.8. Can you see? Then this is what? It gives us what? It's going to give us what? The force multiplied by velocity. Then how to calculate velocity? We say velocity is equals to what? The velocity is changing x divided by changing time. Again. Then we say now we have what? Changing x is 2 meters and time is what? For Temba is 3 seconds. And then for Vose is going to be what? It's going to be 6 seconds. But we know that both of them, because the mass of the object is the same, both of them, they're carrying what? The weight of both is what? Is going to be, we say 50 multiplied by 9.8, which is equals to 490 newtons. Remember, force is measured in newtons. Then because we have a force and we need what? Velocity. We're gonna say velocity is change in x divided by change in time. Then we're gonna say this is for Temba. Power for Temba is equals to FV, and then power for Vose is equals to F multiplied by V also. Then we're going to say what? This V, remember, is the same as what? Is the same as this V. Then we're going to say P T for timber, power for timber is equals to F multiplied by changing X over changing T. P for Vusi is equals to F changing X over changing T, which is the same as what? Force is 490 multiplied by what? Is multiplied by 2 meters divided by, for timber is 3 divided by 3, and for Vusi is 490 multiplied by 2 divided by 6. Are we together? If you have any question, then you can ask the question. Then power for Vusi then is going to be 490 multiplied by 2 divided by 3, which gives me what? It's going to give us 326.67 watt. And then power for Vusi is going to give us what? 490 times 2 divided by 6, which is what? 163.33 watt. Then we see now which one has a greater power. That means timber is the one that applied more power because he used less time. The less time you use, the more power you will have, you will apply. Any question, grade 12? Okay, what's up your question? Okay, this is very, very interesting question. I love this question. It says, the graph below, the graph shows the relationship between the force exerted on the object and the displacement of the object. We see this is the force, relationship between the force and the displacement. It says it takes the object 1.5 seconds to travel 2 meters from here to here. It takes what? 1.5 seconds. Wow. And then they say calculate power. And then because of this, we go back again to the formula. We say what? P is equals to FV. We can start by calculating velocity separately, or we can calculate it together. We calculate what? V, remember it stands for what? Velocity. We can calculate the velocity separately, or we can just put it together in one formula and then continue with calculating it. Then if you calculate it separately, we know that we're going to have what? Change in x, which is the displacement, is going to give us what? Is how many? 2 meters. And then the time is what? 1.5. Then, therefore, velocity is equals to what? Is equals to 2 divided by what? Divided by 1.5, which is equals to 1.33 meters per second. We said the unit for velocity is what? Meters per second. Then we continue, because now we have a velocity and we know the force. The force is equals to 6 Newton. Force is equals to 6 Newton. Then power is equals to force multiplied by velocity, which is the same as what? 6 multiplied by 1.33, which is going to give us how much? is going to give us 8 watt. 8 watt. Are we together? It's going to give us 8 watt. The power is 8 watt. Or you can calculate the power by starting with what? With work. Calculating work first. You can say work is equals to F multiplied by change in X, which is going to be equals to what? Which is going to be equals to force is 6 multiplied by what? The distance, the displacement is 2, which is going to give us 12 joules. Then power, we know power is equals to work divided by what? Divided by time, which is the same as what? 12 divided by what? 12 divided by 1.5. What is 12 divided by 1.5? In meters per second. Excuse us here. Power is measured in not in joules, but in what? In watt. In watt. Ne? Power is not measured in joules. On energy and work is measured in joules, but power is measured in watt. Okay, let's continue. We say this equation is applicable for the force applied caused by an object to move at a constant velocity. Like when you're pushing something and that object, when you're pushing an object is moving at a constant velocity. Constant velocity, it simply means the velocity does not change. You started with 2 meters per second, you're going to end with what? 2 meters per second. The constant velocity doesn't change. And then we say also solve the problems involving power, velocity, and what? And force. All of these, we get them from this formula. P is equals to FV. FV. Okay. Multiple choice question again on what? Power. On what? Power and velocity. It says, which of the following expressions have the same units as power? What is the unit for power? Unit for power is what? Is watt. Ne? Is watt. Which one of these 4 expressions has the same unit as what? As power. And then watt. Remember, 1 watt. 1 watt is equals to what? 1 Newton multiplied by 1 meter per second. Why? Remember, this is what? Velocity. This is what? Force. Can you see? And then we say also 1 watt is equals to 1 joule per watt per second. What do you mean when we say 1 joule per second? This is what? Is for work. Is for work. Joule is for work. And per second, it means that you are dividing by what? By time. That is why we have a -1. That -1 tells you that you are dividing by what? By time. This is what? Is the same as what? 1 watt. Okay. Now we're going to our expressions. In our expressions, we have force. What is the unit for force? Unit for force is what? Is Newton. And what is the unit for displacement? Is what? Meter. Can you see? And then here force is Newton again, and velocity is what? Is meters per second. Can you see? Then energy is joules, and displacement is what? Is meter. Can you see? Then we have work, which is joule, and then what? Time. and time is second. Can you see? That means here we are multiplying newtons and meter. Does that look like this? No, does not. That means this is not the correct answer. Let's go here. Let's go here. This is joule multiplied by meter. Does it look like this? No, does not look like that. Then we have what? Joules multiplied by second. Wow, nearly close. But here we have what? Joules divided by 1 joule divided by 1 second. Now, this one is what? 1 joule multiplied by 1 second. Can you see? Grade 12. That means let's go to number B. Number B is what? Newton multiplied by meters per second, which is the same as this one. Can you see? And which is the same as what? 1 watt. That means the expression that have the same unit as power is what? Is letter B. Is letter B. Okay. We go to long questions. We go to long questions. They say, you're gonna do this. I'm gonna give you 5 minutes to do this question by yourself. I'm gonna give you 5 minutes to do this question by yourself. We say a machine. We first are analyzing the question before you do it by yourself. It says a machine lift an object of mass 60 kilogram to a vertical height of what? Of 5 meters at a constant velocity of what? 3 meters per second. Can you see? A machine lift what? An object of mass 60 kilogram to a vertical height of 5 meters at a constant velocity. That means first, as we did before, we write down the given data. We are given that mass is equals to 60 kg. And then what? Height is equals to 5 meters and velocity is equals to 3 meters per second. Are we together? Now let's go to the questions. Our question says, calculate the force that the machine used to lift the object. Calculate what? The force. Because the object is going up. What is the force? The force that this machine is using, it will be what? The weight or the gravitational force. That means when you calculate the force, you're going to calculate what? The weight or the gravitational force. Are we together, grade 12? I'm just giving you a highlight. Okay. Number 2, question 2 says, calculate the power. Calculate power. Remember, power is going to be equals to what? F V. Force multiplied by what? Velocity. Then, question 3 is what? It says, if the machine uses power of 2000 watt to lift the same object, will the velocity increases or remain the same or decreases? What will happen to the velocity? If the same machine is lifting what? Is using what? 2000 watt to lift the same object. Now, the same machine is using 2000 watt power, is using the same power to lift the same object, what will happen to the velocity? Is it going to be faster? Is it going to be the same? Or is it going to decrease? It will be slower. Okay, let's take 5 minutes. I'm giving you 5 minutes to do all 3 questions starting from now. Thank you very much, grade 12s. Welcome back. Hoping that you enjoyed this question because it's just a straightforward question. And if you still struggle, don't stress. We are still going to do it together. We say now, let's go together to the information that is given there. The statement says, a machine lifts an object of mass of 60 kilogram to a vertical height of 5 meters at a constant velocity of what? 3 meters per second. And you can see here, we managed to write down the given data. They were given mass is equals to 60 kilogram, height is 5 meters, and velocity is 3 meters per second. My grade 12s, when you see height is the displacement in a vertically. It's a displacement vertically. That is, we can use like what? When say height is the same as what? Is the same as changing x, but it is what? Is vertically. It is a displacement. Okay. That means I'm just saying, let me clarify that so that when you do the calculations, you don't struggle. Okay. Number one says, calculate the force that the machine used to lift the object. When the machine is lifting the object is going up. That means the object is no longer on the ground, it's on the air. That means the force that is acting there is what? Is weight that pulls the object down. And we know that calculating weight, we say mass multiplied by what? Gravitational acceleration. That means our forces will be what? The same as the weight. Then we're going to say weight is equals to 60 multiplied by 9.8. Then from the calculator, don't use the calculator always, my grade 12. Use the calculator always because you'll be saving time and you're not going to make any mistake. Use calculator all the time. And the same calculator that you're using today, let it be the calculator that you're going to use when you're writing the exam. Because we don't want you to change calculators. We are used to this calculator. Then, when you're writing the exam, now you are using different calculator. It will take you time to get used to that calculator. And sometimes to find even the keys from the calculator, it will take you time and then you lose a lot of time. Remember, we have only 3 hours in exam. And yes, we have only 3 hours in our exams. Okay. Then we say weight. Our weight is going to be 60 by 9.8, which is equals to 588 newtons. Which is 588 newtons. That is our force. And then all these formulas, you will find them on the formula sheet. You don't have to memorize anything. My grade 12. Okay, let's quickly go to the second question, which says calculate the power of the machine. The formula still says P is equals to FV. We're given velocity again, which is 3 meters per second, and F is the force that we just calculated. Remember, weight is a gravitational force. Weight is a gravitational force. That is why in some instead we write it like this: Fg. G stands for gravitation, and an F is what? Force. Then we say 588 multiplied by velocity is how much? Is 3, which is gonna be equals to 1764 watt. Can you see? Every time after I finish with my calculation, there must be a unit there. grade 12s, if you forget the unit, you lose the mark for the answer. When we mark, we're just going to say 1 for the formula, 1 for the substitution, and we got done. If you didn't put the weight there, if you didn't put the what there or W there, we're not going to mark this last step. We give you wrong on that last step, then you get 2 out of 3. That means it is very, very important, grade 12s, to always, when you complete your calculation, you must put the units. Are we together? Okay. Question number 3. It says, if the machine uses 2000, if the machine uses a power of 2000 watt to lift the same object, will the velocity increases or remain the same or decreases? How can we get that? We can compare. The power that you got here is 1764. You don't have to do the calculation. When they say will the velocity, you see now they just want you only to choose whether it's going to increase or remain the same or decrease. And then by looking at the formula, P is equals to FV. Remember the same? That means because it's the same object, that means the weight is the same. Now, if you increase the power, what will happen to the velocity? Velocity, a force, it doesn't change. It's the same because it's the same object. But if you change power, that means what will happen to the velocity? The velocity will go up. The velocity will increase. The velocity will do what? Will increase. The answer here will be what? The velocity will increase. And then, quick, let's do this together in 2 minutes. It says a worker applies a force of 60 Newton to lift a toolbox from the floor to a height of 0.5 meter in 1.2 seconds. Assume that 1 horsepower is equals to 746 watt. Then they say, calculate the velocity of the toolbox. Quickly, to calculate the velocity of the toolbox, we're just going to say, because we're given what? The force, and we've given what? The set velocity. That means we know that velocity is equals to changing x over changing something is not going right here. Changing in t. Can we take just 30 seconds? We'll come back in 30 seconds.
Believe in yourself. Believe a little more in yourself, because to those that believe, nothing is impossible. You have done this before. You have passed your tests before. You have went into a higher grade before. It is possible because you have done it before. Do not doubt yourself. Keep believing in yourself. Keep pushing, because this can be done and you can be great.
We say velocity is changing x over changing time, which is what we're given here, that changing x is equals to 0.5 meters, and then changing time is equals to 1.2, and then also we're given what? The force is equals to 60 Newton. Can you see quick? I'm trying to do this. Then to calculate the velocity of the toolbox, we're gonna say 0.5 divided by 1.2, which is gonna give us how much? 0.5 divided by 1.2, which is velocity is going to be 0.417 meters per second, and then which is the same as 0.42 meters per second. Now, that is the velocity. Then question 2, it says, calculate the power that the worker applied to lift the toolbox. We're given the force. This is the force here. Then we can say power is equals to F and then V. Then we know the force is how much? Is 60. Then the velocity is multiplied by 0.42. Then we're going to have, then the force, the power is going to be 25 watt. Can you see? 25 watt. Then question 3, it says, express the worker's power in horsepower. They want us to take this power and convert it into horsepower. That means we're just going to say 1 horsepower is equals to 746 watt. 746 watt. Then watt. Then we just do what? And then the watt that we're having is how much? We have 25. We have what? 25. Then in order to have 1 watt here, we just divide by 746 here and 746 this side. Then this and this side we're going to have 1 watt is equals to 1.746 horsepower. Then we multiply both sides by what? 25. Then we're going to have 25 divided by 746 is equals to 25 horsepower is equals to 25 watt. Remember, the power that we have is what? Is 25. We just need to convert this 25 watt into horsepower. Then we go and say 25 divided by 746, which is going to give us is going to give us 25 watt is equals to 0.00 is 0.034 horsepower. That means, therefore, my grade 12, 25 watt is equals to 0.034 horsepower. We have our power now in terms of what? Of horsepower. We have homework here. I'm going to give you a 1 minute to copy everything out on the homework. This is a homework. We're not going to do it. I just want you to copy it out in 1 minute. Copy it out in 1 minute. Thank you very much, grade 12. If you don't have to copy it, if you have a cell phone, you can just take a snapshot and then you'll have it, and then you'll be able to do it. And then that brings us to the end of today's lesson. Grade 12, remember, COVID-19 is still with us. Don't forget to social distance. Don't forget to sanitize. Always wear your mask. Thank you very much. Until we meet next time.